Hello, good morning, boys and girls. So today we are going to work on drawing some Bohr diagram of neutral atom. And I just want to have a quick recap that in the last few lessons we have learned about atomic theory and how elements are arranged in the periodic table. So today we are specifically going to look for Bohr model of a neutral atom. So today's learn, I would like to share my screen. Okay, so hopefully, here we go. Okay, so for today's learning intention are that I can identify the arrangement of electron in an atom. I can work cooperatively with others and I can distinguish the various properties of metal and non-metal. Oops, there is a spelling mistake, so just excuse it. Here we go. So we have to, for this particular example, I'm starting. This particular example is very simple and the quickest one and easy to remember. So this is the Bohr diagram of a hydrogen, and as you see in the diagram, the red dot is the nucleus, and there is one shell around hydrogen atom because it is the first element in the periodic table, and I would recommend you to grab your periodic table and just see where is the hydrogen atom. So I have one example over here for the periodic table. So if you see in this diagram, if you analyze it, you will see that the hydrogen atom is right at the top, and it is on the first row in the first column. So that's why we have only one shell around hydrogen atom, and there's only one electron in the outermost shell. But it's not the same for the other elements. So if you go back and see here for lithium, fluorine, and aluminum, it's different. And why this is different? There is a rule for drawing an electron in each shell. So the rule is that each shell holds a maximum number of electrons. So each shell has a capacity of holding electrons. So the innermost shell can only have two. The next shell after the innermost shell will have eight. And after that, the third shell will have eight again. And so on, it will go as 18 and 18. So right now we are just looking into first 20 elements. So you probably being looking at 288 maximum or 28818. So it will get more clear when you keep practicing how to draw the Bohr diagram. So now here we are with the Bohr diagram. So Bohr diagram, lithium, fluorine, aluminum. They are all three different elements, and they are on different position in the periodic table. So when you see lithium has two shells around itself. So now there are a lot of students asking me like, how do I know that how many shells I have to draw in a particular element? So I would recommend you to have a periodic table always with you when you're drawing a Bohr diagram. So when you see lithium, that is Li, capital L and lowercase I, when you see that, you will notice that lithium is just below hydrogen, but it's not in the first row. It is in the second row in the same first column. So this number 2 represents that how many shells you have to draw around an element. For lithium, it's in the row 2. One is the hydrogen, and the second row has lithium as its first melted element. So you draw 2 shells around lithium. And as we all know, that number 3 represents its atomic number, which is also similar to the number of electrons in a neutral atom. So we distribute, and we also know the rule of how many electrons will be there in each shell. So the first will always have 2. So when you see it here, we have 2 in the innermost shell and only 1 is left. So the second shell will have 1 electron. But for fluorine, it's different. For fluorine, when you see that fluorine is in the same row, 1, 2. So fluorine is in the same row as lithium, but it is on the 17th column, and the atomic number of fluorine is 9. But I know that it is going to have 2 shells around it because it's in the second row, and its atomic number is 9. So how I'm going to draw? I'm going to draw 1 shell, I'm going to do a second shell, and now I'm going to distribute the number of electron. So from the number 9, I'm going to distribute 2 in the innermost shell because I know the 2 will be, only 2 can come in the innermost shell. So I'm just going to put 2. After putting 2, how many are remaining? Right? So 7 are remaining. So where are they going to go? They're going to go to the last shell. So I'm going to put in 2 in a pair. 1, 2, 3, 4, 5, 6, 7. I know this is one electron, but we are going to study later on about its stability. But right now, just for the Bohr diagram, we are going to draw this way. And if you notice, together, if you count the electrons together, you will see that it has 9 electrons in total. The same for aluminium. It's the same for aluminium, is there? And I also want to recommend you guys to uh, to to try and practice Bohr diagram in this particular format. So now here it is valency electron. So what is a valence electron? It's just basically, I just want to give a very simple description of it. A valence electron is the electrons or any number of electrons that are in the outermost shell or outermost shell. So for example, in this particular example of element, you will see that the outermost shell has 1, 2, 3, 4. So these 4 are called as valency electron. That's the only one. And this is a diagram representation of Bohr diagram. This is a diagram. Bohr diagrams are the first 20 elements that we are going to look this year. And atom stability. So what is atom stability? It's just basically unreactivity or reactivity or unreactivity of an element. Here I have taken example of noble gas. Noble gas has full valency shell, so it doesn't take part in any chemical reaction, so it's unreactive. But for the other elements, they lose and gain the electrons in the outermost shell, and by doing this, they acquire their stability. They achieve their stability. So atom stability is gaining or losing electrons. Electron makes atoms into ions, and we are going to look into Bohr diagrams of ions in tomorrow's lesson. So today I want to do some activity. So when you go to the website that I have sent you the link, as you look to the options there, you will see a link. You will see a tab for activities and experiments. So click onto that one, and as you click onto the other sub pages, you will see that there is a link for you to uh, instructing you to go to educa game. So just follow the link, or you can just put educa game into your Google search, and you will go to the website, and you just put the game pin. It's just like Kahoot. Just put the game pin, and it will take you straight towards the page. And there are two matching games that you have to finish. And I want you to do and for this week I want you to do two more activities. That would be an art of making a bow diagram. Maybe you can use a Play-Doh. There will be some instruction posted how to make a Play-Doh how to make a bow diagram using a Play-Doh, and you can use a pipe cleaners to make a Play-Doh, and you just need to click a picture and send it to me through Flipgrid or Google Classroom. And that's all for today. So hope to see you next time. And also, I also want you to follow the other activity, that is when you go outside with your parents, or even if you're in backyard, just try to draw a bow diagram on the soil, and just click a picture and send it to me, and that will be awesome. Thanks. We'll see you soon.